Hello and welcome to a new episode of Coding Coffee with me, Francis Speck. Yes, SQL. Finally, I have a bit of SQL here. I have it on the cup here. Now, actually didn't buy these things, but people associate me with SQL, so I get it as gifts from time to time. You might still be thinking, what do you mean SQL? Structured query language, a way of formalizing the way that we'll save the data for our coffee app. Now, it's been quite some time since the last episode. I kind of been transitioning between jobs and had to kind of get accustomed to my new equipment. So let's get back to Python Anywhere, still the same place as when we left off. If you're following on these tutorials and you have your own account, then having the free one, don't forget to renew it every once in a while so that your app won't suddenly be out of the cloud. So that's the first thing. Then let's go back to our Between Two Cracks app and have a look at the state of things. Now, as a disclosure, and being serious about this, I'm actually in parallel working on still a different app where I play with all the technologies, libraries that I need, and I develop it. And so my original idea was then I know exactly what to do for every tutorial segment that I want to do. So of course this can already give you a taster of what I hope the tutorial eventually might lead up to for you. So this is how it looks here. I'll do a quick login, and I have here a lot of different kind of data to input. Let's just start with the easy one, the coffees that I work with. We have a Congo Robusta. We can have a look at everything that is inside a data record, let's say. So of course this is miles away apparently from where we are with the Between Two Cracks version of it. So if we now go back to the dashboard, okay, and we go to our web. We don't need to reload it at this point, but we do want to visit it. Then let's see, is it still running? It is still asking for that name and the passwords, with which you have to be careful. Trust no one, that includes me. Now let's see. What we want to do, what we did last time, was then just output this to the logs, which is not a consistent way of saving data, and then a nightmare if you would have to retrieve that data. That's where SQL comes in as kind of a data broker, a way of putting data in place for storage or retrieving it. Now, as we're working in Python, we have a tiny advantage, And that being, we can again just choose a library that we want to work with. And in this case, we want to do that with SQL Alchemy. So that's here. How did it say that? The database toolkit for Python. That's exactly it. So it's the layer between what you're doing in your Python program and where you're storing the data. All right, so let's go back to the code where we'll need to make those changes in our app. So we had our hello world, we have the form, so we'll not be making a new form now, we'll just save this in a proper way, instead of just printing it out as we see here. So we need to establish a database. The other thing I hope you still remember is that we have a thing called consoles. Apparently I had mine open here all the time, so it's been a few months. But it's not like this is actively running anywhere. I guess it's just maybe remembering the directory that you were in. In this case, we go back to the between two cracks directory. Okay, here we are. And does it still remember export? No, it does not. So there is a small trick, but actually it's maybe, oh, no, we'll get into that later. First thing is, do we have the IPython available here? Yes, we do. Okay, so we're in the same directory that our Flask app should also have access to. And let's test if it already knows SQL Alchemy on this instance. Yes, it does. Again, on Python Anywhere, a lot of commonly used libraries are just present out of the box. So let's see if we have a quick start. The ORM quick start, that should do the job. Now we want to save data, and then later we want to retrieve it with SQL, so structured. So what does this structure mean? Well, being very explicit about how you define your data, this communicates to this data broker how it will store it exactly, and at a later point in time, still having the same very structural information that you're loading into your program, you then know exactly how to communicate to your data broker again to retrieve that data. And so this kind of structured reasoning about where you're saving your data, or those data tables, that is known as schema. And then you could also call it kind of a data model. And in Python, when we're defining something as a class, then this becomes a class for accessing that model. Now, luckily, the example that SQL Alchemy starts with is something to save a user. Usually, data that comes your way is sent your way by users. It makes for a perfect example. You do not need to convince me on this. All right, let's start from the very first thing, the declarative base. just seeing if we can import this way. Cannot import the name from. All right, that is a pity. Now, what I might need to do is then check what version am I working with. 1.4.36, and here we're looking at the documentation of 2.0. That is, of course, not that convenient. Now, can I... Okay. So that there says 20. And here it says 1.4. If I change 20 by 14, will it give me something? It does. It does also tell me that it is a legacy version. So you might not want to do this when you're trying this tutorial. You might want to go to that more recent version and go from there. Strangely, it does have the same import. No, it doesn't. It doesn't. Now this was in lower case letters. So it's precisely this kind of tiny differences, changes, that for some reason people making these libraries always push through. After many discussions internally, and it will break, and then SQL Alchemy in this example, it is a good example how you should reason about version numbers. So I was just trying to follow a tutorial starting with 2.0. So the major version was a version 2, and that broke. Checking the version as we did here taught us that our installed SQL Alchemy version was 1.4, so that's a major version less. And programmers, developers are allowed by social contract between programmers, developers to do breaking changes when they change the major version number. They shouldn't if it's the minor version number. So if by chance I was, if there existed a 1.5 version SQL Alchemy, it should still have been compatible. But they apparently found themselves roadblocked for how they wanted the project to evolve, so they went to a version 2 on the internet. And once you kind of start a project like this node, so that's one of the reasons I don't want to now just try and install the 2.0 version and get in trouble that way probably, is that you start out with a project, you start out working with those libraries, and some of the dependencies you have, those libraries, they will change. And then if you have time, you can, let's say, import those changes into your project and see if everything's still working. Most of the time you'll have to do a bit of debugging and get everything smooth again, and you won't always have the time to do that. Luckily, you can find the older versions of the documentation, and then you just have to remember yourself where to look. So we do want the declarative base. All right. So just copy paste that and see if that's working. It is. All right. That's just kind of saying the way you want to communicate the model. And somewhere in the documentation, we define module level constructs that will form the structures which we will be querying from the database. This structure, known as a declarative mapping, defines at once both a Python object model as well as database metadata that describes real SQL tables that exist or will exist in a particular database. So through Python code, we're declaring how the structure of the data should be in the backend in the database. And that's why they call this a declarative model. And you have to be explicit on this, that you want to communicate about the structure in that way. So you form an object, or you retrieve it by executing this declarative base. Now this might already also be the reason why they wanted to change this, because executing a function to get a class that you then inheriting from is a bit of a weird way of dealing with Python code, let's say. So that is probably the reason, actually. So we have that base now. Okay, we then copy paste. Should just put this here. Okay, so we made a class. We want to define some users. And here we're putting an attribute to the class saying that the actual table name in the database that will be running in the backend, the table there will be called user account. Then we need a column. So actually, before I go into everything, I haven't imported this column yet, so of course this would break. We have a column, we have an integer, we have a string, column string. We have the relationship. Okay, so let me just do Control A. That kills the line, then Control C. Also eliminates that thing, because first we need to do those imports, as otherwise you cannot build if you don't have all the building blocks. So we'll be using that column in the table. A table without columns would be a poor site. So we need the column, and we'll have values that are either an integer or a string. So the thing that I'm skipping for this exercise is the foreign key. And foreign keys is actually how you link tables. So you might have user data, like their username and their passwords, or a representation of the password. You don't want to save the raw passwords in one table, and then you might have other kind of information like address in another table. Now you might be thinking, why wouldn't you put address in the same table? If a person will only have one address, then you will put it in this one table. If a certain individual might have different addresses, you kind of need the other table to list multiple addresses, and they would link back to this one user, which is then the foreign key in this address table. So that is in the fully worked out example that they're doing in the SQL Alchemy tutorial, but will be diverting a bit from that. So at this point, we should have everything loaded in. We can then again start building up our class. All right. So first thing is an ID. It's just a number. But what does a number allow you to do is to easily jump to a position in a table. So basically you're saying, well, for my table, I want there to be an identifier, just a number. And we're saying it's a primary key, true. What is a primary key? It has to be unique, because if you would say twice, well, 2 rows that have the same identifier number, 3 for example, and you want to jump to record with identifier 3, how would you jump there? You would have to do a split jump. You know, you would get multiple records back, or the program just wouldn't know what you really want to do after that. So of course we have a name, and we have a full name. Well, actually in our case we had a password, and at this point we are going to save it without any further issues, let's say. Well, not concerning the security around it. You should not do this in production, of course, and the next step will be then to at least hash these values. Next step is creating a representation for this data model. This is basically so we have a name, and then we had a full name. I'm not going to show the password in the representation, no need for that. And funny thing is, I actually don't know what this syntax means. I haven't used that myself. I will look it up later. I assume it will just work out of the box. So what you want to do with the representation when you're defining a class in Python, and in your interpreter, for example, you get an object of a certain class. This will then format that object in a sensible way. So in this case, it would just show user and then the identifier and the name. Okay, let's see if this actually builds. It does build. There's no actual backend table, so I am curious how that will now go. To have an actual backend, we need an engine. So the data broker, as I referred to it earlier. Let's get that engine. All right. And engine equals create engine SQLite echo true future is true. Indicates that SQL emitted by connection will be logged to standard out. Future is to ensure we are using the latest SQL Alchemy 2.0 style APIs. Okay, that will be the future, although we are still in the past. You see, sometimes when they then don't maintain a previous version, they already do make references or optional changes to already adapt yourself when you are ready to upgrade to their newer library version. Now I am curious, it's just saying SQLite. We normally use memory only database. So when you just have it like this, it will just create it in memory. which is fine. When we then want to save it after this 2 forward slashes, we'll then just write a file name, which in theory should be saved in the local directory. So our engine is working. Okay, what's happening now? Emit create table. Using our table metadata and our engine, we can generate our schema at once in our target SQLite database using a method called metadata create all. Yes. Base metadata create all. Okay, so that command is sitting here. So we have our declarative. And of course, the model that we made here used that base as its parent class. And so now we're again addressing the parent class, saying metadata, please create all the tables I need, and so has succeeded. Alrighty. Create objects. Of course, at this point, there's nothing sitting in the database, which is a big pity. And then to actually put things there, we'll need to work in sessions. The session takes the same engine. And what then just happens is SpongeBob. So here they're making users with addresses. So more complicated than what we're doing. We'll just have a little more boring. User1 equals user. So how is the syntax there? We did have a name equals, oops. Okay, and we'll just make it as boring as humanly possible, because at this point it's not a safe database. Again, you do not want to use this in projection, but at the very least, it is kind of easy now for us to create 2 users. I could leave it just the way it is. We haven't forced the names to be different. And upon creation, setting it up in the database, they will get a different identifier. I am quite confident about that. You then have to still add them to your session. So just creating an object from this data representations isn't enough to get them to your database. It is enough for the metadata. So the base declarative model was used to create the specific data models, and in this creation, their metadata was already linked with the base declarative model, and so that we could then use to kind of push these tables to the database. But the users, well, at this point in any case, we hadn't even created them, but even if you would have done that as objects, you couldn't have done the session at all at that point, because you would try to send it to a database that doesn't know anything about a user table. Now, just adding them in a session like this would also not be enough. What database exchange is like is that once you've done everything that is relevant in a single step for you, so in this case I'm doing 2 users, a more sensible thing is when you're actually having one user and he has his addresses and they go to different tables and that all kind of sits together. So you're kind of preparing all the data for these different things, and then at the same time you say, well, now I really have all the data, I've prepared everything seems to be in order, I'm ready to just commit this and really save it. So you're kind of in a working place up to the point that you say commit. Will this work? Fingers crossed. Oh, add all takes 2 positional arguments. Oh, 2 positional arguments, you say. You don't, yes, and I did give 3. So that's the little mistake here. Add all. You could just do add and then have 1 by 1, but it's expecting a list. So you see here, insert into user account table with those kind of specific values. What we see printed out here is actually the SQL language directly. So what SQL Alchemy in Python is helping us do is allowing us to communicate everything in Python syntax, and then in the backend it changes all this into SQL queries. It's called a query, and it forwards this through the engine to the backend database, which in our case has been just an in-memory data table. At this point we have them here, and we now do want to find kind of a simple select. We want to retrieve that data. Okay. I'm curious to see just what kind of things do we have on this. Right. Okay, so select session. Well, we still have a session actually. So we want to select a user. Can we just select user? Where? Statement. Session scalars. Well, okay, so let me fix this. So you can see I did make a select objects. When you execute something in this interactive shell, the last line that you ran, that will be represented by the underscore. So now I kind of assign this value to the statement, and we'll just do a quick check. Will this return anything to us? It does, and it's showing that representations that we did. Now, why does it look like I don't know what I'm doing? Although in the beginning I showed you that I seem to be already a lot more advanced with my website. Well, the reason for that is that I jumped directly to using sublibrary of the SQL Alchemy, Flask SQL Alchemy, that deals with the sessions and everything in quite a different way and makes it easier for calling them from within your Flask views and kind of to operate within the logic of a web session. But I thought it's more kind of informative also formative to abstract a little bit in this first exercise from the website that we're also trying to develop for our coffee notes and just work directly with SQL Alchemy, although it means we have to be a bit more verbose on certain things. But as you could see, at this point we basically did everything to structure a data table, put some data in the backend, although this was now in memory. We'll now do a test to see if we can actually get that user data from the front end. So to do that, we basically need almost all the statements we did. So you again, I don't know if I showed this in a previous tutorial, but if I didn't, within IPython, you then ask just the history. And you see, we haven't done that much basically. This just includes everything, faults, good things, bad things, just everything. And all right, basically we can now just go here. We'll comment this out. We don't need to just print it like we did before. This looks very messy, very much messy. First thing, we want to we don't need the general SQL Alchemy. That declarative base we can't use. That was from the first one. So this is good for backtracing our steps. Here we were in the correct version. We need the declarative base. Right, let's just make database. And we'll have to do a small trick though, now that we'll try to run it to the website. Because we had kind of two parts. It's creating tables, again, getting user input. Now the user input we're getting from our fabulous front end. But creating the tables, once a user arrives here, that should have been dealt with. So we kind of need to separate those processes too. All right. Base, declarative base. So this doesn't actually go in the view. This goes in our database segment here. And I'm putting it in front of the form now because, yeah, you should get your data in order before you go out there, let's say. Those one we do need. Now the relationship we haven't really been using, but okay, let's leave it like that. And then the class with the representation. We move here, so using the declarative base. We kind of need the engine. We need it both for creating the tables and when metadata create. Oh, okay, so this is the first section, right? And I want to kind of build in a check. If our database file exists, then we can kind of skip a part. We can just create the engine or fire up the engine, let's say. if it doesn't, then we want to create the tables. So if OS path exists, and we'll just call it cnodes database. If that exists, echo true, future true, cnodes database. And so I'm putting it this way because I think at the moment you do that, it will just reload it. But if it didn't, you need to do the same statement, but then you know at least this one time you need to create those tables. Now, in the future, when you start changing tables, creating additional tables, this becomes very messy to kind of have to find checks in how you would do this. And then again, it would be a lot more convenient working with the Flask SQL Alchemy or other, maybe SQL Alchemy has strategies for that as well. At this point, let's just see if this will give us anything. Okay, we have the sessions. All right, that import is also important, although we don't need it for the table creation. Now, it is considered a best practice having all those imports just sitting on top, even if at a certain point or certain run of your script you're not actually using it. I guess this one was the ones that failed. We had the add all user. In our case, we will actually not need an add all for the simple reason that once one user wants to be added, submits the form, there's no two users present. We can simply check, you see session add. So instead of session add all, session add will just, expect one instance of this model. Exactly. All right, so then we go back here. We don't need to do that. Okay. With session engine as session, exactly this is now exactly where we want to be. We have our user model defined here. Now for the name, we take form name data, and then form password data. So instead of just printing, we now first step creating this. We don't need the second user for this example. We don't need to do add all because our form just gives us information for one user. So this can all be deleted. But of course, having added a user, we do want to commit that. This part, I will now comment out because what we want to do is see if we can capture the data. How we treat it afterwards, we process it afterwards, we analyze it afterwards. That is for a lot later. Of course, we have to see we're not messing up our code. We still need to render If even if this code would be here, in theory, it might not break it. Although it's missing, I think, the session. So it would break. If we created a session outside of this, but you don't want to do this in the web application, it probably would have worked. But when this runs, when the server starts up, that's the idea. Of course, we will have to see if it's. I would put my money on the fact that it breaks. So it is saved. Now let's reload it and see if it still actually can start up. I should just assume it's better to directly go to the errors log, open link in a new tab, so the files, just as a reminder, you go to the root, which is sometimes tricky because it's just before this home, that slash there, then on the var, where you see the logs, and here we have the error log, right? So that's the one. At this point, we see this is from November last year, so it's not reporting on an error. But if we now refresh this, will it? Something went wrong. Of course, something went wrong. So now refreshing our error. Error. SQL alchemy. Invalid SQLite URL. C notes. Okay, doesn't like it this way. So the SQLite URL forms or its memory, or like that. That was the one that we did the tutorial with. So this one we know. Or, haha, you just have to add one more slash to get that relative path I was hoping for. All right, all those slashes. First step. Of course, you might try and guess how many mistakes did I make in this code? How quickly will it start running? This is part of programming life. You make something, you then sift it to get all the bugs out. But it's simple enough, you know. You know where you go to look at the errors, and then you try and try again. Here we have the form. So probably, and let's do this just step by step. We have our bash thing here anyway. We don't need to exit. No, we'll exit because we need to, in any case, later. Later we have to, how to say, we have to connect to this new database, not the in-memory one. So a bit of a small disappointment. Not, oh, the C notes is standing there, not within between two cracks, but apparently the working directory is the home directory. So at this point, if we then do a cat, so that again, cat from concatenate, but if you just do this on one file, it shows you the contents of a file. And this isn't really just text, this kind of SQLite database, but you can still kind of see what's inside. So it's kind of creating this table. That's the first step we did. And that's actually what happens when we do a reload, it executes that code. So when we did it the first time, at this point, it already broke and it left the Flask app dangling, unfinished. So Flask realizes like, okay, I cannot load the web app made by Francis because there's a bug inside. And then when you ask a URL, it just says, well, something went wrong. Not an internal server error. That's something when you get when you are able to process the first layer of your app, and then in a certain view you get an operational error, so that the view can generate, and then it will usually say internal server error. You know, just two examples. It can always go wrong at very unexpected places. But Francis pick. Will it process? Will it process? It did do. And now we have Francis Bacon. All right, we're on a roll. Now let's go back and have a look at, did anything change here? Oh, yeah, something is here. Apparently we're not able to read, but we can see our data is already being saved, probably because part of the things that we were sending are ending up here. So last thing to do for this episode is retrieving the structured data in a structured way. And for that, we can actually kind of already have what we need, which is we need to get our engine back. All right, so we need that engine. And that's the same one we're addressing here. So, okay, oops. We also need a session to work with. Okay, but especially we want to select our users to see who we have in our database. Select. So I think this at this point will fail because, oh no, the user is not defined, of course. Aha, now this is where it gets interesting. We define the user in our between two cracks. From between two cracks, import user. Import sys path and so we know where it's sitting, just beneath us, because it's an unknown location. It is an unknown location, yes. So apparently our app is starting from this home directory. Now we kind of need to get access to the model. And it's not called between two cracks, the Python file, sorry. And it's not in the local directory, so then we're trying to add the subdirectory between two cracks in which it would look for Python code in theory, and it's called Flask app. So I now hope that I won't fire up a second app, but we did get the user from there. So we can now try again. To select it. All right. We still need a session though. Okay. So we got this session also from the ORM. And then engine. Okay. And apparently with the select and running this on this model and having that must then somehow have been able to retrieve where it's coming from. Or is that doing it from the session here? Given the fact that this is very confusing for me, I imagine it is even more confusing for you. But we do have the two Francises inside of our database. When you have this kind of a for loop, at the end of it, you can actually ask something about the last item that was assigned to that variable. So that will be here with ID2, and we can now see what was this? What password? Bacon, not me. All right, so we covered a lot of territory here. We learned something about alchemy and structured query language. We didn't learn anything about NoSQL, but yes, SQL, we got a little introduction into it. So now possibilities are endless. At this point in the course, you have a way of making forms, though we saw limited kind of fields of putting things there. You now have a way of starting up a database, although the course itself really is only a starting point for you to see where you find documentation, how you reason about version numbers, and in theory, when you're replicating every kind of line I do, you should get the same result, but this doesn't really help you building up your application. For that, you kind of first have to now start thinking, what kind of data do I want to collect? You can first do the exercise thinking about Excel tables or any other kind of tables in your notebook, handwritten, whatever. How would you structure it as a table? How would you link different tables together? And in theory, we touched upon like, okay, that's how you save it, that's how you can retrieve it, and then of course on the website, once the data is in there, you then kind of want to share it, just like we have here in my database, where, well, this is where I would put some data in it, and this is where I can have a look at all the coffee I have tasted. So let this be an inspiration for you as well. Happy coding, happy SQL for coffee, and hope to see you on the next episode.